In lesson 7.1, we're reviewing completing the square, which is a method to solve a quadratic equation. So remember that quadratic equations are always in the form ax squared plus bx plus c. So I'll refer to those, the coefficient of x squared as being a, the coefficient of the linear term as b, and then the constant as c. So you'll need that for some of the formulas today. So before we actually get into completing the square, let's do a problem that shows us why completing the square makes problems easy to solve. So if we look at a problem like this is a fairly simple equation to solve because what we need to do is square root both sides to eliminate the squared term on the left-hand side. So if I square root both sides, I'll get x minus 3 equals plus or minus the square root of 7. And then to isolate x on the left-hand side, I just need to add 3 to both sides. So fairly simple, right? Only 2 steps. So the goal of completing the square is to get every quadratic equation to be one of these easy little 2-step problems. Okay, so here's a quadratic equation, x squared minus 4x plus 2, and we're going to use the completing the square method to solve. So let me write it bigger, x squared minus 4x plus 2. Okay, so the first step is we always want to make sure that the leading coefficient is 1. And in this case, that step's already done for us. So I'm going to skip right to the second step, which is to move the constant over to the right-hand side of the equation. So to do that for this problem, I'll subtract 2 from both sides. Now I've left some space here intentionally because when I complete the square, I'm going to be adding a number to both sides of my equation. And the number that I add is using the formula b over 2a squared. Now I just said that we're always going to make sure our leading coefficient a is 1, so you can also just think of this as b over 2 squared. Remember, b is the coefficient of the linear term, so in this problem that's negative 4. So we have negative 4 over 2 squared, which is negative 2 squared, or 4. So if I add 4 on this side, that completes the square on the left-hand side. What that means is the left-hand side of the equation will be a binomial squared. So if you think about factoring this left-hand side, it would be x minus 2 times x minus 2. So that's the whole purpose of doing this b over 2 squared. It completes the square. Now, because it's an equation, you have to keep it balanced. So whatever you do to one side, you have to do to the other. So if I add 4 to the left-hand side, I have to add 4 to the right-hand side. Now, by doing that, we have a problem like the previous example. Nice and easy. You just square root both sides. And that's the whole goal of completing the square, is to get to that point where it's just a nice, easy 2-step problem where we take the square root of both sides and then isolate the x. So if I add 2 to both sides, now I have solved for x, which is 2 plus or minus root 2. Okay, here's another example. In this case, we have 5x squared. If I rearrange it so that it's equal to 0, we have minus 30x plus 100. Now, step number 1 is always to make sure that the leading coefficient is 1. In this case, I notice that every number, a, b, and c, are divisible by 5. So for this problem, I'm going to go ahead and just divide both sides of the equation because that will make my leading coefficient 1. So I have x squared minus 6x plus 20 equals 0. And now I start the process of completing the square. So step number 1 here is going to be to go ahead and subtract the constant, so move it to the other side. And then to complete the square, I need to add b over 2 squared to the left-hand side, but since it's an equation, you also have to do that to the right-hand side. So remember, the number I'm putting in there, I'll do it off to the side here, is b over 2 squared. So b is the leading coefficient of the linear term, excuse me. So then we get negative 3 squared, or 9. Whatever you do to one side of the equation, you have to do the other. Again, remember, the whole purpose is doing that completes the square on the left-hand side, which means it makes it a binomial squared. And that binomial, if you think about factoring that, would be x minus 3 times x minus 3. And then on the right-hand side here, we just add those two numbers, negative 11. So that's it for the new part. That's completing the square. Now it's just a nice, easy problem where you need to take the square root of both sides and isolate x. So you have x minus 3 is plus or minus the square root of negative 11, which if we isolate x by adding 3 to both sides, remember, you can't leave your answer like that. Just before the final exam, we learned about imaginary numbers. So if you have a negative under a radical, you need to change that to I root 11. Okay, this next one here also doesn't have a leading coefficient of 1, but each number is not divisible by 3. Now, there's two ways that you can deal with this. One way is to do just what we did in the last example, is to go ahead and just divide both sides by 3 and get x squared plus 4x plus a third equals 0, and just deal with the fraction. That's not that big of a deal. So you would move the constant over. You would complete the square. So that's b over 2 squared. So our b is 4 in this problem, so it's going to be 4 over 2 squared, or 2 squared, which is 4. So that completes the square on the left-hand side. This is going to be x plus 2 squared. And on the right-hand side, we're going to think of 4 as 12 thirds, so minus 1/3 is 11 thirds. That completes the square. We go ahead and just take the square root of both sides. We isolate x by subtracting 2 from both sides. And then we also remember we can't leave radicals in the denominator, so we quickly rationalize for our final answer of negative 2 plus or minus the square root of 33 over 3. Now, another method that you do need to know, because we're going to be using this method when we start graphing quadratics later, is where we deal with that leading coefficient in a little different way. So let me show you this way. We have 3x squared plus 12x plus 1 equals 0. So in this method, you go ahead and just move the constant over first. So I'm going to subtract 1 from both sides. Now, I can factor a 3 out on the left-hand side because 3 goes into both 12 and 3. So I'm going to complete the square here. But I'm going to look just inside the parentheses now for my b over 2 squared. So my b in this case is 4, which is just like what it was in this other problem. So this part's the same, 4 over 2 squared, which is 2 squared, or 4. But now the key thing in this method is I have to keep this equation balanced as usual, but I really didn't add 4 to the left-hand side. I added 3 times 4. So this needs to become a 12. That's the big difference with this version. So again, the point of completing the square is that this becomes a perfect square. So that's x plus 2 squared. On the right-hand side now we have 11. Before we take the square root of both sides, we'll divide by 3. We have x plus 2 squared equals 11 thirds. Now you can notice I'm just at the same point here. So everything after this is the same. All right, that's lesson 7.1. Your homework is on Schoology.